Hey guys, in this video we are finishing up Unit 6 and we're going to be talking about two things, geometric probability and changes in the dimensions of figures. So geometric probability is used to find the odds or the probability, not area, that a point will be located in the shaded region of a shape. So we're finding if we have a shaded a shape that's part of it's shaded, and we were to throw a coin at it, we want to know the probability that the coin would land in the shaded region. And so to do this, we take the area of the shaded and we divide that by the area of entire figure. So we've got to find the whole entire area and the shaded area, and we divide. And that's going to give us the probability. All right, so number one, let's find the area of the shaded first. So this one, I have a parallelogram with a rectangle taken out of it. So the parallelogram, the area of the parallelogram is 17 by 18. Which is 306. The area of the rectangle is 5 by 8, which is 40. So the shaded region is 306 minus 40, which is 266. And then the area of the whole figure, that was this 306. So we're going to take 266, that's the area of the shaded, divided by the whole outside figure, 306. And you get point like 869, but we're going to give it as a percentage, which would be 86.9%. So we have about an 87% chance of landing in the shaded region. Okay. So here we have a trapezoid, and I would do a trapezoid with a rectangle cut out. I wouldn't find the triangles probably. So let's just say the area of the trapezoid is half times the height times my two bases, 20 plus 14. And we get 204. The area of the rectangle is 14 by 12, which is 168. So the shaded is 204 minus 168. Which is 36. So I'm going to find the probability. We take the area of the shaded divided by the whole figure, which was the trapezoid. And we get 17.6%. Number 3, we've got two circles. So let's find the area of the large circle first. And this one, it does mean that this whole length right here is 7. Okay. And then this part is 4. So the area of the large circle is pi times radius squared. So 7 squared. Dividing that in half. So pi times 7 squared is 153.94. The area of the small circle is pi times 4 squared, which is 50.27. And so the shaded region would be, I have the 153.94, and I'm cutting out the inside. And we get 103.67. Okay. So my probability is going to be 103.67 over 153.94. And we get 67.3%. All right, and number 4. All right, so we have the area of the large rectangle. So the whole outside is 11 by 18, which is 198. The area, I'm just going to call these 1 and 2, of rectangle 1 is 4 by 5, which is 20. The area of rectangle 2 is 2 by 5, which is 10. So the shaded region, 198 minus 20 minus 10 is 168. So the probability of landing in the shaded is 168 divided by that whole figure, which is 198. And we get 84.8%. Now, the next thing that I want to talk about is, what about if we have a rectangle, but we like double the size of the rectangle? And what happens to the area? What happens to the perimeter if we do that? And the best way to look at that is to just use an actual example, use actual numbers to figure this out. So for example, here we have a 3 by 5 rectangle. So let's just find the area of this. And we get 15. Then let's find the perimeter of it. So that would be 3 plus 3 plus 5 plus 5, which is 16 inches. Now what happens if the dimensions are doubled? This becomes 6, This becomes 10. All right, well, let's find the new area. Area is 6 times 10, which is 60 inches squared. The perimeter is 6 plus 6 plus 10 plus 10, which is 32 inches. All right, so what happened to the area? It went from 15 to 60. That is 4 times bigger. So it got 4 times larger. What happened to the perimeter? It doubles. This will be true for any of the shapes. If you double the side lengths, then the area quadruples. If you double the side lengths, the perimeter doubles. Let's look at another example. Find the area of the triangle. All right. Area is half times base times height. That's 30 inches squared. And the perimeter, 5 plus 12 plus 13 is 30 inches. Now let's assume the dimensions are tripled. This becomes 15, this becomes 39, and this becomes 36. All right, now the new area. Half times base times height. And we get 270 inches squared. And the perimeter, 15 plus 36 plus 39 is 90 inches. So what happens when the area, or what happens to the area if it's tripled? The area gets 9 times larger. And the perimeter gets 3 times. It triples. Well, messed up. It gets 3 times larger. So the area, because area is squared, if you're doubling it, that means you're multiplying by 2. So the area would be 2 squared times. We got 4. If it triples, your area is 3 squared times larger, so 9. Let's say we multiplied each side length by 4. The area would be 16 times larger. If we multiplied by 5, the area would be 25 times larger. Okay, so that pattern just continues to your shapes. If you have any questions, let me know. Have a great day.